SUNLU sent us a pile of humidity-sensitive filament and their new dryer, the SP2. So what are we going to print? Well, today we are making two very functional items. First, this strange-looking shape, and second, this frog. While you can tell what it is, what if I told you it's a very functional item as well? To create them, a 3D scanner, Autodesk Fusion, and even a little Blender tutorial will come into play. We'll also see how the SP2 stacks up against the SUNLU S2 we've been using. And as promised for months, you'll find out why we don't put our PLA in bags, even though the average humidity is over 60% in our city. Stick around, and by the end, all will be revealed. This is the story of the SUNLU SP2. Well, mostly. This is gerGO, and you're watching gerGO Print 3D, the YouTube channel where my little nephew and I are having the time of our lives playing with fire, colorful plastics, and awesome devices. Just like our last 120 or so videos, this too comes with carefully curated transition-ready subtitles, detailed chapter markers, and audio tracks in over 20 languages. First, a quick update on our 10,000 subscriber milestone. Thanks to all of you, we are approaching it much faster than expected. We are planning to commemorate it with Levi this weekend, so please watch for our community posts and live stream announcements to celebrate with us. You all got us here so quickly that we've decided to move our special chocolate printer project closer to Christmas, which feels even more appropriate, and we will have the parts by then. Speaking of that project, our sponsor, PCBWay, has already manufactured the stainless steel components. They've passed quality control and will be shipping soon. It has been the smoothest experience ordering these CNC milled parts, which were based on the same CAD models we first prototyped on our 3D printers. You can also count on their industry-leading expertise and vast array of machinery to take your project to the next level, whether it's for PCBs, laser cutting, milling, or 3D printing in quantities or materials your home printers cannot handle. We promise to keep you updated on this project, and a big thank you to PCBWay for helping make our dreams come true. This whole video really started when a big package arrived from our friends at SUNLU, packed with a fantastic selection of their filaments. Right away, these colorful PETG spools got us excited. We often get PETG only in white and black. We already have a plan for this specific shade of blue, and especially this glow-in-the-dark green. In just a few minutes, you'll see what it is. They also sent a great selection of high-temp materials like ABS and ABS-PC, which I can't wait to test in our upcoming SVO8 Max videos. After all the upgrades we've put into the Max, building the enclosure and its riser, adding the heaters, upgrading the tool head cover, and even perfecting the sealing, we'll finally be pushing the limits with high-temperature printing. Then there was this little surprise. I thought this rainbow spool was also PETG, but nope, it's PLA. It's beautiful, but it made me realize that pretty much every other spool in this box is sensitive to moisture. And with the humidity here over 60%, they all need a good drying section before we can actually use them. And just as I was thinking about that, as if they were reading my mind, another package showed up the very next day. Inside was the SUNLU FilaDryer SP2. It's their new dual spool dryer and looks like a big upgrade to the S2 we've been using. But before that comparison, let's see where we are coming from. Quite quickly after starting this hobby, I realized the necessity for a filament dryer. My very first attempt was this fun DIY project made from a simple food dehydrator. It was better than nothing and a great learning experience, but it lacked precise temperature or drying time control. Then we received a number of dryers to test, among them the SUNLU S2 from Geek Buying. While drying can salvage some types of filament, PLA in particular is irreversibly damaged by humidity. The long polymer chains in the material break down and the plastic becomes incredibly brittle. You might be able to melt a ruined spool like this down into something simple and functional, but not much else. That's why I first got into the habit of storing spools in IKEA freezer bags, which later got an upgrade to the vacuum bags from AliExpress. But with all the various material changes to be able to keep the spools loaded, I had to take the fight to the next level. And here's the answer. Late last spring, we sealed the tiny 3x3 by 3 meter printer room and installed this Solis PD16R air dehumidifier. Using a smart sensor, it keeps the ambient humidity around 30%, which is fantastic compared to the 60% average here in Budapest, filling the 3-liter water tank in about 10 days on average. So basically, we turned our printer room into a filament storage area. The SUN-off THSO1 sensor and smart switch combo made it easy to program a daily 3-hour de-icing break and even keep a log of the dehumidifier's activity using a simple Google Apps script. According to this, the machine runs about 33% of the time, 7-8 hours a day, using about 12 kilowatt hours of electricity per week, which comes out to about €2 or $3 at residential electricity prices in Hungary. You can decide if something like this is worth the convenience of storing PLA out in the open. AliExpress links to both components of this setup is in the description below, and comment if you need help setting up the smart switch. I'm happy to help. The target 30% in the printer room is still a bit high for sensitive materials like PETG, ABS or ASA, not to mention nylons. These we will still keep in bags, and for these you still need a dedicated dryer right at the printer, capable of drying not just before but also during a print. For a long time, that role was filled by our SUNLU SP2. It stood its ground well, reliably supplying sensitive filaments to our Chiditech Q1 Pro and H2S for high-temp prints. The only problem? It couldn't physically stand its ground. The tall, narrow S2 was just too unstable for our hyperactive H2S, which dances around so aggressively that the dryer was a constant tipping hazard. It got so bad that during one particularly violent print, I had to run to our lightning-fast FS on S1 Pro to quickly print this stabilizer just to save the job. I'll admit it's not the prettiest accessory, but it was absolutely necessary for the S2. The SP2, of course, solves this problem with its wider, bulkier design. It sits securely on top of the bamboo and doesn't budge. For me, the stability alone is worth the upgrade, but of course its double capacity and space for bigger spools and its function as a storage box are all welcome improvements. I filled up the hygrometer's box with desiccants, a peculiar design kind of distorting the readout during drying, but a good way to measure the effectiveness of the desiccants when used as a long-term storage box. Added the 4 rollers, plugged in the base, and we are ready to roll. With the SP2 now reliably feeding our bamboo or any other printer, it was time to print something useful. Remember that strange shape from the beginning of the video? The first mystery is about to be solved. See, we recently got this new trinocular microscope from AliExpress, a really high value investment, part of the electronics bench I'm building for low-level modding and fixing our printers in the future. It came with a high-resolution camera, ring light, Barlow lenses for a wide range of magnification levels, and even this ugly dust-covered bag, which I very much don't want on my desk. I'm sure we can come up with a much more elegant custom-fit cover just for the most dust-sensitive eyepieces and the camera. After a quick 3D scan using our wireless Otter Light from Geek Buying, the same scanner we used to rescan Levi after a year of growth spur, and some design work in Fusion 360, the model already looked very promising. I printed a quick PLA prototype on the lightning fast FS on S1 Pro, tweaked a few more angles and clearances. The next iteration can be printed using the light blue PETG that SUNLU sent. Not only does the color perfectly match the silicone matte we got with the scope, but the bright color also serves a purpose. It's a visual reminder to actually use the cover and protect the optics when I put the microscope away. Not strictly necessary for PETG, but let's test the dryer during printing the H2S, something its AMS2 cannot do while printing. Off to a good start, I set the dryer to PETG and noticed the suggested drying temperature was just 50 C. That's a very conservative default for a filament with a glass transition temperature of around 80 C. Bumped it up to 55 C for the time being and set the timer to 3 hours to match the print time of this dust cover. I was able to feed from the back left hole on the top using the longer PTFE tube for the AMS2. The print started okay, but soon I noticed the narrow plastic spool was misaligned on the rollers and the printer struggled to pull the filament. I ended up removing the second spool and installing the roller shaft. The user manual recommends smooth side up, but the high quality SUNLU plastic spool glided very smoothly on the other side as well. The filament must have come fairly dry because the dryer reached 20% humidity level in just a few minutes. By the end of the clean, completely stringing free print, it was all the way down to just 10%, a full 50% lower than the ambient humidity this rainy November. So let's see how it fits. A perfect custom fit cover that protects the three most sensitive optical components, the two eyepieces and the camera port. And when the microscope is in use, the cover has its own dedicated spot right next to it, keeping the desk clear. Another mystery down. Now let's see what that frog is about. SUNLU also sent this awesome glow-in-the-dark green PETG, our first glow filament out of PETG. Levi asked for this cute frog model we found on MakerWord. We will scale it up 400% because he has a great idea for how to use it. Making it out of PETG will hopefully make it a bit stronger and more flexible even if we print it without infill. Although the H2S would be capable of multicolor printing, I thought it would be much less wasteful to print the green and black parts separately. The eyes and mouth were surprisingly easy to separate in Blender. Tab for edit mode. We set select mode to face. Click anywhere on the eye and use Ctrl and the plus on the numerical keypad to extend the selection to the entire eye. See how it selects inside the frog? Mesh, separate, selection. Reselect the main body, then modifier, add, generate, boolean, difference with the separated eye. Apply. And just repeat for the other eye and mouth. And export each part as an STL. If learning a quick trick like that in Blender was helpful, there is just one more click you could do on that like button below this video. It's a huge help for the channel and lets us know you enjoy these kinds of deeper dives. Thank you so much. We used the Creality K2 Plus to print the black pieces, while I loaded the green PETG in the SP2 and attempted to thread it into the printer. But this glow-in-the-dark formula made the surface of the normally slippery PETG much rougher, the difference being very visible under the microscope. So rough that it took immense effort just to push it through the first segment of PTFE. I did not even dare to feed it further into the printer. I ended up replacing this section with the tube included with the dryer, which I noticed had a larger inner diameter. Then I managed to get it all the way to the extruder. As a testament to the strength of the H2S extruder, it was able to then pull in the filament, though with some struggle. That's when I remembered a trick we learned during our eye dryer tests with the SVO8 Max. I set the dryer to a much higher 65C, which made the rough PETG just soft enough to finally feed reliably. The proof? When I tried lowering it to just 60C, the printer immediately threw a feeding error. Bumping it back up to 65C let the print finish without another problem. And while I was using the dryer, I found a neat little feature. If you select the SUNLU logo and adjust it, you can cycle through a few lighting modes. There's a cool animated one that pauses while it's heating up and then turns solid once it hits the target temperature. A nice informative one. Now, a quick but important warning about any glow-in-the-dark filament. It's abrasive and will wear down your nozzle. I was curious, so I checked the stock hardened steel nozzle on the H2S under the microscope after this print. Compared to a brand new spare, I couldn't spot any wear after about 150 grams of printing. So the bottom line is a hardened steel nozzle is a must. Definitely do not print this with a standard brass nozzle or you will risk ruining it very quickly. Oh, you wanted to see how that glowing frog turned out. I have to tell you about this dryer first. So after all that, what's our final verdict on the FilaDryer SP2? It is way more stable than the S2. It can hold 2 spools and the 70 Celsius max temperature is more than enough for PLA-G, should even be sufficient for drying most ABS or ASA for our high temp projects. The fan noise, however, is noticeably higher than our year-old S2. 52 versus 46 decibels measured from about half a meter away, though the S2 has a more irritating high-pitched component. I would not recommend running either in living spaces. So you might think your printer has a filament dryer built in, but they are usually quite limited, both in terms of max drying temperature or even in functionality like the MS2. And the SP2's filament storage capability, using these airlock plugs and a digital desiccant health monitor, means we don't have to use vacuum bags for another 2 rows of humidity-sensitive filament. The price of just the storage unit without the heater is very reasonable. If it wasn't this bulky or we had more space, I would consider switching to these for all our sensitive filament. The SUNLU SP2 isn't a flashy upgrade. It's an essential tool that reliably works in the background to solve real-world problems and make all your projects successful. For us, it was the direct solution to a frustrating issue with our hyperactive bamboo, and it has earned its place in our workshop. And our beautiful glowing frog will also find its place next to Levi's bed. Before I get a chance to give it to him, I tested it with my bedside lamp. It provides a magical afterglow after turning the lamp off, just as Levi imagined. I'm sure it will work great for him too. We have so many more projects and reviews like this on the way. If you don't want to miss our 10,000 subscriber celebration or the high temp tests on the SVO8 Max, make sure to click subscribe and turn on notifications as well. What's your solution to filament drying? Have you tried SUNLU SP2? What would you have printed with this green glue plastic? Let us know down in the comments. If you're interested in any of the products shown, we'll have links in the description below. A final check on our counter. Thanks to all of you, we are fast approaching 10,000 subs. Celebrate with us soon in our very first live stream with Levi. We have big plans. We're going to be printing and unboxing and have a lot of fun. If you haven't yet, be sure to watch how this American bamboo lab got to us. It's truly the story of the year. Or if you're curious about the 3D scanner we use today, we make a strong case for why you might need one in this video. Either way, let's go print 3D. Thank you for watching another gerGO Print 3D video all the way to the end. Keep them dry.